last session. Yeah, and it was a very interesting session because if you look 2 years back, we were all busy building data centers, and today we are all busy looking at AI and machine learning and liquid cooling. So that is, and one good thing about this industry is that what I've seen is that everybody is collaborating with each other. And this session is one of them. And I find it very interesting that we have problems in hand, but we are converting it into an opportunities. So thank you all for being here with us. And I'm sure that we are going to have an interesting conversation here with the panelists. And you can introduce yourself after first question. So the first question here is, what are the emerging trends into the liquid cooling, and what is interesting for you and why?
I'll start. Hello, everybody. So we're going to talk about liquid cooling in general, hybrid liquid cooling. My name is Akash Ajmera. I'm the founder for Konnect, and we are system integrators for liquid cooling technologies across the board. So to answer your question, Mohan sir, is that the different liquid cooling technologies that are emerging in the market are direct-to-chip liquid cooling systems, single-phase liquid cooling systems, and two-phase liquid cooling systems. Out of which, if you ask me, and I've been asking in the market as well, the most prevalent technology right now and the most adopted technology right now is going to be for the next 2 to 3 years is going to be direct-to-chip technology, wherein you're using a CDU system connecting to a cold plate given by the hyperscaler or the end client, and letting the technology coolant do its job in terms of cooling the system as per the NVIDIA guidelines. Going forward, we have the immersion technologies coming into play as well when the computes become higher. But as of now, I see the direct-to-chip being able to cater to the requirements of the data centers being installed and fitted right now, because you can actually install the current chiller system to your D2C CDU systems and make it functional.
Cool. Hi, I'm Mark Roberts. I'm from BP Castrol. I explained a little bit earlier the position of BP Castrol and BP's transition to an integrated energy company, and as part of that, looking to help industries to decarbonise. And obviously, I heard the phrase power guzzler earlier on, and I think that aptly sums up the data center industry. And the part we're playing within the Castrol brand is to look at the liquid cooling fluids. So we provide fluids for both the direct-to-chip and for the immersion on the single-phase side. Perhaps, obviously, Ashok, you've mentioned the kind of technologies, just in terms of the market data we're seeing as well, and just to back up what you're saying. So as we see now, well, let me just step back. Air's not going away. Even into the future, air's not going away because of the different landscapes, and not everything will be AI. So that's important to say. The other important thing, as we stand here today, probably around 83-84% in 2024 is air. And what we expect, that remaining 17%, most of it is direct to chip. Fast forward to 2028, we're expecting to see the actual immersion cooling start to take off, to be around 40% of the liquid cooling market. And overall, we're expecting liquid cooling to rise to 33% in a market that's pretty much going to double as well. So the overall cooling market will pretty much double. So that is significant growth. Within product development, not specifically on the hardware side, but what we're seeing from a fluid in tank perspective. So we've got a couple of standard products, but we're already developing. The topic of sustainability has been quite a big one today. So we're looking at sustainable fluids. We launch our first one next year, which is a re-refined base oil. So from a sustainability point of view, it's 99% sustainable for immersion cooling. We can't get to 100%, unfortunately, because of the additives that we put in there, but that gives you an example. The other things that we're definitely starting to see, and even today, and we've been at Supercompute in Atlanta this past week, and we're starting to see the precision or cold plate cooling or directional cooling within immersion as well. We even showed some of the Grace Hopper 200s sunk within immersion. So this whole area is very much an active and a dynamic one, and changing on a constant basis. Over to Roopesh.
Thanks, Mark. Yeah, thanks, and good evening to all. I wish I could disagree with Akash and Mark, okay? And I'm sure that most of you will agree with me that we have a free cooling, right, in all our data centers. I mean, even in Chennai, 24 hours, 7 days, 365 days, we could have a free cooling, okay? That could be the best thing to happen, right? But then I know that it is not practically possible. So I have no choice but to go with them and align with them, collaborate with them, and then find out a solution. So the trick is to kind of how to perfectly balance the various cooling technologies that can support your varying cooling load and the varying densities and strike the right balance, and then keeping the energy efficiency in mind, your energy cost in mind, your infrastructure in mind. So that is what I think that the whole industry is working towards, especially with the very dynamic cooling requirements coming to us after this AI burst, like the AI workloads, which is asking for many different varieties of cooling, as they mentioned about whether it's a liquid immersion cooling or a direct to chip and air cooled. Many combinations are coming. Even most of the direct to chip liquid cooled racks, they already have as a requirement of some percentage of air cooled also. So that's a kind of way the industry is going now. And then definitely we all have to work together and see how do we kind of bring that hybrid cooling, where we can kind of have a very balanced approach towards this data center cooling.
Yeah, Roopesh, the next question goes to you only. At what point you start thinking about the liquid cooling or air cooling? When do you start thinking about it?
Yeah. So Mohan, if you remember, around 15 years back, right, when we had this cloud computing came in, so we all kind of looked at that as a monster coming, right? So we have a power density of 10, 12 kilowatt thing. So we thought that is going to be, the future, right? But then over the period of time, we are seeing that it's kind of increasing. Now we see that the densities are increasing of 40 kilowatt, 60 kilowatt, 80 kilowatt, 100 kilowatt. That's the range at which it is going. So uh, when you know that no more you can do with an air cooled systems, but thanks to the industry or the technologies, that to a great extent what it was 15 years back and now, the densities with an air cooled thing handle also has gone up very high. So now cooling a 40 kilowatt rack with a simple air cooled system is not an impossible thing. It is almost becoming kind of a regular thing, right? But then yes, when you look at beyond that, definitely you need to look at a hybrid system or a liquid cooled systems. It can be anything. It can be a DCLC or it can be a LIC or whatever it is. But then that is where you start looking at the different approach, because heat removal is not an easy process. So I often say that electrical is easy to handle because if you switch on, the light will anyway glow. But then cooling is not like that, because the dynamics of water and air is totally different. So you need to have the kind of technologies that will help you to kind of handle these things. So I would say that when you have the right kind of servers and the racks which demands maybe above 40 kilowatt kind of a things, you should definitely start thinking about an alternate cooling mechanism and then start designing on that.
Thank you. Yeah, Mark, you want to add something?
Yeah, maybe just to share a little bit of a previous life. I've only been with BP Cash for 5 months. Prior to that, I was at a rack power cooling infrastructure company, and I was very fortunate to work with an organisation called WitterFX, who are based down in Wellington in New Zealand, little sleepy New Zealand, and that organisation actually does all the rendering for films like Avatar and Lord of the Rings, King Kong, etc., etc. So I've been very fortunate to be able to work on their data center since 2009, and we actually got up to 50 kilowatts earlier this year with air in a completely enclosed system. So it begs the question, why don't we just use air? But the trip over point is then becomes the chips and the changes with the chipsets that just won't allow us to use air anymore. So I think that goes in hand with what Roopesh is saying there. Thanks.
Thanks, man. Akash, you want to add?
Yeah, so my answer actually resonates with what just Mark said because this entire, you asked a question, when do you see the tipping point to liquid cooling? So the question actually lies with the load as well as the OEMs of the servers as well. So the day the chip manufacturers start governing the points that we need this to be cooled by liquid is the time when all the hyperscalers and the colo providers will start following suit. That's how they're going to set it up. In addition to that, the colos also have to look at a point wherein efficiency has to matter to them because that's one of their major metric on which they charge the customers as well. So that will also be a point of contention wherein if I'm using an older rudimentary technology, is it still giving me a efficiency good enough for today's world? If it's not, then let's switch to the next technology. So it's the OEM drive and the efficiency part as well.
Yeah, so now we have started considering liquid cooling very seriously. So the next question which comes to his mind is what are the factors we need to consider when we are designing our data centers, specifically the greenfield data centers?
Yeah, so we wanted to look at this from two angles. Okay, so one is the greenfield. Okay, that I would say may be relatively easier because you have many options now, may have many systems in place, and we need to look at two aspects mainly, or I would say three aspects. One is the electrical distribution part of it, and then your cooling thing and the network part of it. So most of the other things are pretty standard these days. But then these three things definitely need a good upgrade to handle the new age kind of the AI workloads, right? So your electrical distribution is no more the same simple, 1A, 1B or 2A, 2B. It has gone much beyond that. So for example, the NVIDIA system, they need a 4 and 3 kind of a design, right? So that is different from the traditional way of distribution. Then if you look at the cooling, obviously, so that has different, totally different concepts of that, right? So the way you, choose the temperature. So that is one biggest challenge for service providers like us because many of this, I mean the servers, I'm sure that you would have gone through that while designing that, right? So what happens is that as there is no standardization as of now, everybody comes and asks us different set points. I'm sure you all will go through the same challenge, right? So we have requirements coming from, say, varying from 21 degrees to 30% of degrees of water temperature. So it's not easy to kind of provide that in the same kind of an environment. So on a BTS model, built-to-suit data centers, I agree, this is possible. But then a colo providers like us, this adds a lot of changes in our design, the way how we design the modules into that. So that started I mean making making all of us to think of different options. How do we kind of design this greenfield data centers to adopt these new technologies? There are ways around that, and there are technology around that. It's again a collective decision making. I would say that it is a very closely knit ecosystem, like from the user to the service provider. This is a collective process where you kind of design this new data centers that will take this the AI kind of a workloads.
Thanks, Roopesh. Mark, you want to
Yeah, again, just to add a little bit more. So one of the things that we're being asked about time and time again is around weight as well, especially going to the example of the brownfield sites and the slab ratings, so the concrete slabs, and whether they have the capability to actually take some of these systems. So pretty much we've seen around 12 kPa as the norm. But with some of the immersion tanks, we're up at around 15, 18 kPa for the point load. But even when we start looking at some of the larger CDUs, we're obviously talking about megawatt, we're talking about 1.5 megawatt, we're now talking about 2 megawatt CDUs. The actual point load is significant. So we need to think about, from the ground up, this slab rating right from the beginning. I do know the consultant engineers are on that game. So obviously moving forward it's a little bit easier, but for brownfield a little bit more challenging. The other thing, just thinking about it from the fluid side, how are you going to get that fluid in there? And we're being asked to quote PG25 containers in isotainers. So how are you going to get a container full of PG25 into your data center? How are you going to receive it? How are you going to decant it? How are you going to get it where it needs to be? So all of these need to be considered as part of these new designs. So yeah, quite a change for all of us.
So while designing greenfield, I just feel one point is that we have to be. I mean, a colo or any data center provider has to keep in mind that they have a couple of different clients who they're going to cater to, who have different load requirements, right? So what is the best sweet spot for us to actually design an air cooled along with a direct to chip or an immersion? So I would say that we have to have, as Mark said, a floor loading defined, of course. But in addition to that, we set up sections or sectors or clusters in our data center in a way that this part of our data center, in case it's not a hyperscaler, if it's a retail, if it's a hyperscaler, then the floor goes to them with their design. But if it's a retail customer, they can actually set up clusters which cater to from the same chiller system for a air cooled setup. Then the same chiller system caters to a direct to chip setup and so on. So we can have that hybrid connectivity between the couple of systems and actually create a design which uses heat as well, reuses heat as well from the colder systems and send it across to the systems which require more heat reuse. So that's something we can implement.
So a couple of years back, my client used to, at Jacobs, they used to come and say that design a data center suitable for hyperscaler colo. And now I'm still getting an inquiry saying that design it for hyperscalers, colo, and direct liquid chip cooling and liquid cooling. So what I have learned from this is like for the greenfield data centers, generally we do the risk rating and the risk analysis. I think on the technical part also we need to start thinking after AI what something is definitely going to come because we have built this data centers for expanding for 5 years or something and we just finished the phase one. So similar thing is going to come. So that's really interesting. So my next question to Roopesh, like how are the service providers geared for the hybrid cooling?
Yeah, so same thing what Mark and Akash also said, like being in a colo is slightly difficult in the sense, as I mentioned, if it is a built-to-suit data center, it's relatively easy. And like Akash mentioned, if it is a single floor with single tenant, is easier to handle. But then look at the case where you have enterprise customers scattered all around, and out of 100, they may have 5 racks with liquid-cooled requirements. So that is where you need to have a strategy to kind of, or the design that can kind of cater I mean, different kind of technologies, right? So, for example, I will tell you. So, in a typical perimeter cooled data center, you have few racks which needs and liquid, I mean, cooled, systems. Thanks to the, the air to liquid systems where you can have a sidecar kind of a thing, so that will still absorb the air and then give you a liquid back to your racks. So it's going to be a completely mix and use, systems when you come to kind of, this kind of enterprise data centers, and where we need to cater different kinds of loads. So even then this liquid coal also, what we are seeing is that it is not kind of again everything is kind of 20 kilowatt or everything kind of 40 kilowatt. It's varies, right? So depending on the hardware what they choose, they may come and ask for a 20 kilowatt liquid cooled racks or a 40 kilowatt liquid cooled rack. So we need to have their systems in place. So it's not only like the entire data center which is kind of designed uniformly across, but you also need to have address the scattered or the isolated requirements of this rack densities also. So good that the industry has responded well on this, and then we have different kind of solutions and products available that can actually cater to these kind of requirements. So I see that as a very positive thing, and then we are going to see the real-time use and implementation of that in the coming months.
Thanks, Rupesh. So the next question to you, Mark. Like now we are considering this liquid technologies and a lot of fluid which we are using. Uh, what are the challenges? Means how do you handle those? How do you maintain the quality of those fluids? Can you throw some light on that? And also the second part of the question is that we have a lot of components which are immersed into the fluid. So what are those challenges?
Yeah, it's certainly something new, and one of the things that that is good is events like this and panels like this because it provides people with evidence of collaboration. And I spoke a little bit earlier today about the importance of collaboration because when we think we might put a Dell 9680 in some immersion fluid, 300K each, you want to make sure that there aren't going to be any problems. So we have to work with the chip guys, obviously, the servers, so the Dells, the Supermicros of this world, the HPs. Then we need to make sure that we're working with the components guys. When I talk about components, might be memory like Samsung, or it might be people that do the power cables or the actual fiber connectors. All of those we need to work with, and then we get into to working with the likes of the guys from Stultz, Schneider, Vertiv. They're all part of our ecosystem. So we need to make sure that we're cohabiting nicely with theirs. And then we come into the data center. And this is where, obviously, the whole idea of bringing the kind of volumes of fluid that we're talking about is new. And we need to work with the guys to make sure that they are comfortable in how to handle it, how to service it, how to maintain it. One thing that hopefully came over earlier today is when you put this fluid in, whether it's PG25 for the directed chip or it's immersion fluid, the chemistry of that fluid will change. You have to monitor it, you have to maintain it. You need to maintain it in the same way that you maintain your crack units today, your fan walls, etc. And every 6 months, send it off for a lab analysis as well to make sure that everything is okay, because we have introduced that single point of failure into the system. So if the fluid health is not healthy, then we have significant problems. So that's where we introduced our liquid cooling centre of excellence just outside of London, and that's why we work with all of the ecosystem to make sure that we can support the adoption of both types of liquid cooling, because as we said before, both will coexist well into the future.
Yeah, right?
Yeah, so there are or were a couple of challenges with liquid cooling for sure with the liquid, and I really appreciate this question because that was one of the major pointers that I also faced as a system integrator when I went out to sell the immersion fluid. The first question that came to me, is it environmentally safe? Will it cause leaching to my components? And is it going to be safe for human beings to handle this? So the good part is that the OEMs of these liquids are responding. The Chemours of the world and the BPs and the Castrols of the world are actually responding to these technical queries. They're doing constant lab testing, and I know for a fact that the Chemours 2P50 liquid is actually compatible with all your networking components. They're doing in-house testing with Cisco in a large scale, and they've been able to make this liquid function with networking components as well. So you don't need a separate stack in liquid cooling for the networking side. In addition to that, they've also taken care of the environmental aspects like global warming, ozone depletion potential, and they've made sure, and I'm sure the single phase liquids are doing the same, where they've made sure that the environmental impact is as low or nil as possible, and ensuring that the continuity of using this liquid is not going to create any long-term damage. With respect to the human aspects, that can only be defined by continuous testing. So you have to have your toxicity analysis, you have to have your sustainability analysis on each and every liquid. Once that happens, once you have that data, it becomes much easier for you to actually deploy these liquids in real life scenarios.
Thanks, Akash. And it was a very important point, right? And it's great that everybody, all of us sitting here are thinking about it, okay, the environmental concern, and we are addressing those issues. So it's really a great thing that we are doing collaboratively. Last question for all the panelists: is liquid cooling is the best way to keep it chill?
Oh, that's a subjective question, and today I have a big bias, so I don't know if people are going to believe me with terms of liquid cooling because I have a stall set up with liquid cooling. But anyways, yes. So as Mark mentioned in his previous, I got to know this information right now, but when he was in his previous assignment, he was working with the likes of the avatars and all the other graphic processing industry, where he did 50 kilowatt air cooled data centers as well. So that is there. But the point of discussion comes in that, are you efficient enough at that particular point of 50 kilowatt with air cooled? Are you still maintaining the same integrity of the servers by running them in a high temperature environment for so many months or years and overclocking the servers at higher temperature? Are you really doing justice to those servers? In my opinion, no. So the liquid cooling is going to come in to take care of all the questions that I mentioned. It is the inevitable solution because we all know that the loads are going to be increasing every day. 2 years prior to this, when I was in the market, people were talking about 25 to 30 kilowatt loads. Already the standard RFP in the market across different hyperscalers is 132 kilowatts per rack. So to cater to that heat rejection, we have to go to liquid cooling. And it's the best possible way to be sustainable, to use least amount of water, and to have the best efficiency in terms of PUE. You have a PUE of approximately 1.5, 1.6 in an air-cooled data center compared to a less than 1.25 PUE across single phase and dual phase. So it's actually a no-brainer. If you can set up the back-end piping and infra, you should move to liquid cooling in the future.
Cool, thank you. I think going back slightly to what we said before, is it the best? In some instances, it will be the only option. I think that is one point. We've obviously talked around it mainly being a data center play as well. So I'll change that to the edge. And one of the interesting things and one of the challenges we spoke about actually deploying a technology like immersion may be the existing building. So I know during a couple of panels and a couple of presentations today, people have spoken about the edge. And of course, whilst AI is in training, it will be in those large data centers such as the Sify data centers. And but it won't always be there. And we'll need to move that AI out of training and into inference, and that will need to be deployed closer to the people, so to the edge. And that, I think, presents an opportunity for us with immersion, being able to deploy in containerized type environments, closer to the people. I think there we might be able to experiment a little bit more. Temperatures is one. So obviously, I come from, despite the accent, a country that can get quite hot in Australia. And we do have some of those challenges. If we can increase the actual temperatures in the tanks, then that gives us the opportunity for dry coolers. Say bye-bye to the chiller and all the power consumption, etc. However, that needs our friends, the chip guys and the OEMs to come to the party as well. And I say that because some of specifically in the direct-to-chip, we're seeing some approach temperatures on fluids that are actually cooler in some hyperscalers than their current air temperatures going into the data center. So sometimes it goes back to performance, it goes back to efficiency, it's trying to trade it. Yeah, so maybe it's a horse for a course, which is the best technology for which environment. And yeah, so maybe Edge might help to accelerate immersion in the next couple of years. Roopesh.
Yeah, Akash, I thought you are going to give me 1.01 PUE. Okay, so jokes apart, maybe I would still keep it, and I will go with the same our subject line, keep it chill with hybrid cooling. Okay, because the industry has to reach to a maturity level and kind of agree to kind of a common points, where we can kind of adopt a single technology or a kind of, a common platform. But then till that time, I feel that we will still do customized hybrid solutions specific to the applications, and then we'll continue with that. So mostly I see that this hybrid cooling, that is a mix of air cooled and it can be any kind of air cooled, and then the liquid cooling coexist for some more time, and then we move towards that that standardization, and then we kind of taking maybe a much better and mature technology thereafter. That's my take.
Thank you, Roopesh. And we don't say goodbye, but I think we'll meet again to celebrate the success of liquid cooling and try to resolve another problem and find an opportunity. So thank you so much for being with us, and I really appreciate it. Thank you.